Hi, this is Umair back with another Java programming tutorial. In this tutorial, I'm going to be talking about some advanced concepts in programming, that is data structures. If you don't know what is object-oriented programming, because that is required for learning data structures, I have already created a video about OOP practices. I have given the link of that video in description below. Make sure you check that out and learn object-oriented programming before watching this tutorial. So what is data structures? Data structure is a container of data. It lets us store data more effectively. Execution and manipulation of data becomes easy and fast with the help of data structures. It provides a bunch of ways to store data. Large projects contain complex requirements. Those projects need to be more fast and user-friendly. There are many requirements. Those can't be implemented without data structures. So I'll be showing you different techniques, different algorithmic ways in this tutorial in order to solve those problems, in order to meet those requirements that we face while developing large applications. There are many things that can't be implemented without data structure. Data structure provide a bunch of algorithms that can be used for working with and solving those problems. So what are the different topics I'll be covering in this tutorial? These are the topics that I'll be covering in this tutorial. These things, stack, queue, linked list, hash tables, trees, and graphs are already available in built-in libraries, are already built-in classes in Java and other major languages. But what is the purpose of this course? Obviously, you are here to learn programming. You are here to sharp your programming skills. So I'll be writing my own custom classes of stack, queue, linked list, sorting classes, hash table classes, tree classes, and so that if when the built-in classes don't contain any specific function that you need in your applications, you must know how to write your own custom class of stack, queue, linked list, or any other data structure. You must know how to write specific function that you want to use in your application. So the purpose of this tutorial is to let you know that how to make your own library, just like you import any other library in Java, like you import a random class, you import generic classes, you import array list classes. You must know how to write these kinds of classes. So I can assure you that you are going to learn a lot in this tutorial, because I'll be covering each and every topic that you are looking in my screen with different examples, with the real life examples, and I'll be going into depth of stack, queue, linked list, sorting, hash table, trees, and at the end I'll be making a small application that will include all the above concepts that I have already explained, that I'll be explaining you in these bullet points. So before starting it, I just want to let you know that I told you as well in my previous video, I have created a group on Facebook called Programmers. Make sure you join that group. I have given the link of that group in description below, and follow me on Twitter as well. So first let's start with stack. So what is stack? Stacks works like LIFO manner. LIFO stands for last in first out. So what do I mean by it? Let's say that I want to add, actually stack works with two data structures. One is array and other is a linked list. So first I'll be showing you how to work with stack with the help of arrays, because if you are here to learn data structure, I assume that you already know what is array. Alright, because it's a basic level concepts, and I'll not be talking about the stack with linked list because I need to teach you what is linked list first, and after that I'll be working with stack with the help of linked list. So what I'm doing right here is showing you how to work with stack with primitive types like character, integer, float, double values, and I'll be making my custom class with the help of these primitive types. So you can see that if I want to add a value inside an array, I will push that value onto that array. Let's say I have pushed 2, and above 2 I have pushed 4, above 4 I have pushed 6. Alright, so what is last in first out? First I pushed 2, after that I pushed 4, after that I pushed 6. So at last I pushed 6. Alright, whenever I want to get any specific value from a stack, I can't get this 4 or 2 before popping this 6. So in order to get 4, I need to pop 6. In order to get 2, I need to pop 4. So whatever I have pushed last time needed to be popped up at first. Alright, so there are 4 main things that you need to be care of. One is the index of array in which I have pushed the last value. Let's say it's 0 index, it's 1 index, it's 2 index. So I need to be care and need to reserve a property of a class with the name top that will contain the index number where I have pushed the last value. If I want to push another value above 6, I need to increment this top by 1. So top will take care of the index where I need to push the last value. Alright, and after that I need to take care of size of that array. Alright, size will contain the total capacity of this array to contain the total values for working with the stack. Like before starting working with the stack, I need to reserve a specific size for this array, that this much size I want to reserve for this stack to work with. Alright, if I want to work with a stack of students in a class, I know that students can't exceed 100 limit. So I will set the size of this array to 100 and this size will contain the total length of that array. So this is the second thing that we need to be add in our custom stack class. Another thing, these are the 2 important components and concepts that you need to be take care of. Whenever I put a value inside an array, it's called pushing a value. Alright, and whenever I want to fetch any value from that stack, it will automatically fetch the upper value from that stack. So that is called popping a value. Push and pop. Alright, so these are the 4 things that need to be take care of while writing your own stack class. So now let's start writing our stack class in our Eclipse. Alright, so I have created this empty project. This is the main method. So I'm gonna create my own custom stack class. So I'm gonna be creating this class. Alright, and I have let's give it a name int stack because I want to put values of integer types into the stack. Later on I'll be working with objects. I'll be pushing and popping whole objects, whole student object, person object, employee object, and that object will have another properties and functions. So you don't need to take care of that right now. Just focus on what I'm doing. I'm gonna creating int stack, and inside this class I'm gonna be assigning those properties that I've just shown you right here. Alright, so let's go right here, and I'm gonna write private int, and for storing the size of stack I'm gonna set a property to empty stack variable. Alright, and then after that I need to set the top and the total size of the stack. Alright, so these are the 3 properties that I have set. The top will take care of the last index where we have just pushed our values. Right now I want to add a constructor int stack, and inside it I want to set the default values inside those properties of this class, and I want to set the default it might be a case that user don't want to give the values to the stack. It just want to go with the random stack uh, properties configurations. So we also need to add a default constructor. Alright, so for the stack I'm gonna give it a size because I've given the size of 50. So here I need to set the size of 50 as well. Now let's create another constructor if user wants to send some values for the size. So I want to set the size, and I'm going to copy this code and paste it right here, and replacing 50 with the size. Alright, and I'm going to give it this dot size because this refers to this property of this class, and this size refers to the formal parameter in the constructor. Again, inside it, let's add this dot size. Alright, so I've set the constructor and the properties of this tag class. Now we need to add two major functions inside this class. One is a push, another is a pop. So we have top variable that will take care of the index where I need to put the next value. So let's add a function public. For now, in order to check if our pushed value is working pretty well, let's add its return value called boolean, so that later on we can also check that if our value has been pushed or not. So I will add a push function. Alright, it's giving me an error because I need to return some value. So let's increment top because the default value of top is -1, and -1 doesn't exist in arrays, so we need to first increment the top value before pushing specific value inside our stack array. Alright, and then after that I can set the top as an index of stack array and set the item to that index. Alright, and then after I will return true. Alright, so before writing the function for pop, let's add a function public boolean is full, and I will return if top equals to stack dot length -1. Alright, this function is gonna check if we are able to push another value inside our stack or not, because if we have pushed 50 values, because let's say the size of stack is 50 and we have pushed the 50th value inside our stack, then we can't push another value inside our stack. So for that we need to check with this function if we are able to set a specific value inside stack or not. So I need to add a condition right here as well. So I'm gonna write is full Alright, let's add a code inside here. Alright, and after that let's return false. Alright, when we will test this stack, we will see that if the size of stack has been increased to the limit, then it should return false. Otherwise it should push the value and it should return true. Alright, now let's add a new function called pop. So while popping a value, the return type should be int because all the values of stack are of integer type. So let's add int and pop, and I will return the stack top minus minus. It will get the value while setting out the index of the stack with the variable top. So it should be decremented once it will return that value. Alright, so what do I mean by it? If I want to pop this 6, right now the top is referring to the second index. After popping the 6, the top should be pointed to the first index, because after popping 6 the upper value on the stack must be 4, so the top should be pointed to 4. Alright, so that's why I've decremented right here. Alright, and for the pop, I also need to add another function if we have popped all the values of the stack or not. Like if our stack is empty, then we shouldn't be popping any specific value from the stack. Alright, so for that, let's add a new function, public boolean is empty. I need to first check if the stack is empty or not, and return top equals to -1. Alright, so now I have set different functions and the properties. So I think we can, if we want to add another function that should be available in our custom int stack class, then we can also write that specific function. Now it's time to test this stack class out. Alright, so now I need to go and make an object of int stack. Let's go with the default constructor right here, and it will assign the size to 50, top -1, and set the stack array to 50. Alright, so now I need to first check if the stack is full or not. Alright, so let's add some values inside our stack. So if int stack dot is full, not is full. Alright, if it's full, we shouldn't be pushing any specific value inside our stack. If it's not full, then I'm gonna write int stack dot push, and I'm gonna add 2. Alright, and most probably you will be taking input from users, but first, just for testing purpose, I'm pushing values by my own. So let's push 2, then 4, I'm gonna add 6 and 8, let's say 9. Alright, so I have pushed 4 values inside an array. Alright, and after that, let's pop the value system.out.println and .pop. Alright, you can see that I have not given any specific index that this value should be popped up. It will automatically get the value that is on the top. Right now the top value is 9 because last time we have pushed 9. Alright, so now let's go and run this. You can see that it has printed 9 because last time we pushed 9. Alright, let's copy this line and paste it right here, and check this out. If it is popped up right here, the top should be decremented, and once the top should be decremented, it should be pointed towards 6 because the second last time we pushed 6. Alright, now let's run it. Check this out, the output. You can see that it has printed 9, then 6. So the sequence of popping up the values is opposite to the sequence of values with which we pushed these values. So our stack class working pretty well. If you have any question related to this class, make sure you comment below. I'll give you the answer of your questions. Alright, so working is fine. If you want to add more functions, you can add this out now. Next, what we'll do is in real world examples, we don't work with stacks with primitive types, integer types, double, characters. Rarely you might have get a chance to work with it, but most importantly, you will be using stack for mathematical calculation purposes, like if we have a calculation like 2 multiply by 3 plus 4. Alright, you have set the precedence that 3 plus 4 should be calculated first, and after that it should be multiplied with 2. So in order to check if the starting brackets are equal to the ending brackets or not, so this is the application that you can use with the help of stack. In programming many other applications, the function calling also work with stack. The recursion return function returning also based on the stack, and there are many real world examples. Alright, next I'll be making my class, person class, and I'll be implementing that stack with that person class. So let's do that. So now for working with stack that could contain the objects rather than this primitive type int, float, double. So I'm gonna create a new class called person in order to work with the stack. Alright, so let's right click on it, and I'm gonna create a new class called person. Alright, so I'm gonna give it few properties. So I'm gonna give it name, and let's say it is a student, so I'm gonna give it a roll number class, and I'm gonna give the form of parameters inside a constructor. Alright, so this dot name equals to name, and this dot roll number equals to roll number. Alright, so I've created a constructor. I'm not going to create accessor or getter setters, but I need to override its function, and that would be public string to string return, and I'm going to return the name and roll number both. So I need to concatenate it with name and roll number, concatenate with roll number. Alright, so I've created this model, a pretty small model, but it will be enough to test the stack class. Right now this is the int stack. I need to create a new class called person stack. Alright, and I need to copy this whole code. I don't want to write each and everything, and I'm gonna modify this class. Let's change the name from int stack to person stack, and this array of stack is not of integer type because I want to store the items of person type, so I'm gonna change its data type to person. Alright, so let's change the name of constructors from int stack to person stack and change it person right here as well, person right here as well. Alright, so rather than sending out the integer type item, I'm gonna send out the person type. Rest of the things are pretty fine. Alright, so now rather than returning the integer type, I'm gonna returning an object of person. Alright, so you can see that I have modified this class from integer to person. These are the things that are needed to check if the size and if the stack is empty or not. Alright, so far so good. So right now I've created this person stack class and person class. Alright, so now I need to test this class out. Alright, right now let's comment this code. Alright, so let's create two objects of person so that I'm able to push these person objects in the stack. Alright, so person, and I'm gonna send out the name, and let's say the roll number is this. Alright, let's create another person object. Alright, so now I have two objects that I can push into the stack of my person stack class. But before that, let's create an object of person stacks to access the functions of person stack class. So stack equals to the new person stack. Let's use the default constructor of person stack class. Now with the help of stack, I can push person 1. Alright, let's copy this line and paste it below. Alright, so you can see I have pushed person 1 first and person 2 after that. So the top will be referring to the person 2 object. Now what if I pop an object from that stack? It should pop up the person 2 first, because last I pushed person 2 object. Alright, so now let's get the stack dot pop. Alright, and I need to call its toString function. Alright, so what it's gonna do, it's gonna pop up the last item that I pushed. Lastly I pushed the person 2 object. It's gonna return me from this function, and it's gonna print out, it's gonna call this function, and it's gonna print out this thing. Alright, so I need to copy this line. Let's check this out if it's returned the person 2 object or not. So let's run it. You can see that it has returned and printed out the person 2 object. It's working fine. Let's copy this line and paste it right here as well. Alright, and run it. You can see that it first popped up the second item that I pushed last time, and after that it has popped up this value. This was earlier pushed. Alright, so you have got the idea how to work with array stack with the help of objects rather than working with primitive types. So next we'll be working with the queues. Queues have simple queue, circular queue, and I'll be also talking about the working with queues with the objects just like this. So let's start working with queue. So now let's talk about what is queue. Queue works in a FIFO manner. FIFO stands for first in, first out. Let's say that we have an array and we have add a new item inside an array. Let's talk about the integer primitive type array. So I have add 2, and then I have add 4, and then I have add 6. So first I added 2, then 4, and then 6. In stack, if we pop the item, 6 will be popped up. In queue, the first in first out means the 2 was added first. So whenever we want to fetch any item from an array, the 2 should be fetched first. Alright, anything that has been fetched first will be get first. Alright, so there are 4 main things that are needed to be considered in queue. So adding item inside a queue is called enqueue. Alright, and whenever we want to get an item from a queue, it is called dequeue. Alright, and for working with it, for writing the code and this algorithm work, we need to consider 2 main things. We need in stack we were having a variable that was focusing on a specific index where the last item have been pushed. In queue there are 2 things that are needed to be considered. Alright, so we are looking at that we need a variable that is a front, alright, and the front will focus on the specific index that have been just added in the array. Alright, and another one is the rear. Rear is the tail of array where the first item was added. Alright, so it will point towards 2. Alright, these 2 variables are for whenever we want to add a new item, we will add it with the help of front, and whenever we want to dequeue any item, like we want to dequeue 2, the 2 will be dequeued and rear will start focusing on 4. So the real will be used to dequeue any item, and front will be used to enqueue a new item on the specific index. We'll work later on that how to work with it when there are two items and the two items are on the last indices of the array. Then how to work start from the 0th index of that array. So that's called the circular queue. So I'm going to be writing a code. I'm going to be writing my own custom class of queue and writes few functions inside it. So let's do it. So I have created a new project with the name queue, and inside this project I have a main file, main.java, and I'm going to be creating a new class called queue. We are working with the primitive type first. So I'm going to name it int queue. Alright, so this is the class that I'm going to be using for writing my queue class. So first we need to have an array that will contain all the items. Then we will have a size of int type. Then we will have total items, how many items are in the array. Alright, then we will have front, then we will have rear. Alright, so again I'm going to be writing a constructor, default constructor. So I'm going to set its size to 100, total to 0, front is 0. At start of working with the queue, the front and rear and total will be 0. Total will handle the total number of items in this array. Alright, so rear will be 0, and I'm creating a new array with the size. Alright, so this is the size. Alright, now let's add a custom constructor where user wants to add its custom size inside it. So I'm going to be copying this code and paste it right here, this one. Alright, so this dot size equals to this size. Alright, let's add this dot size. So I have created two new constructors. Now let's add the two main functions. One is the enqueue and other is the dequeue. Alright, so let's go and write that function. So I'm going to be writing public int, first one will be enqueue. Enqueue have the item. But before writing anything inside this function, I'm going to add a new function to check if we are able to add a new item inside this queue or not. Means if the queue array is full or not. So I'm going to add a function is full. It's going to check if the array is full with the items or not. So I'm going to check if size equals to total, then return true. Alright, and inside the else I'm going to add a return false. Alright, and let's come to the enqueue function, and inside it I'm going to call this function. If the array is full, then simply return false, that we can't add a new item inside this array because the array is full. Inside the else I'm going to add enqueue a new item inside that array, and as I mentioned earlier that the rear is handling the index of that array where we will enqueue our new value. Alright, so I'm going to first increment the total variable so that the total variable will contain all total number of values inside that array, and then I'm going to use that queue array and I'm going to use the variable for specifying the index in the array, and I'm going to put this item, and after that I'm going to increment the rear so that the next item, whenever we want to add, whenever we want to enqueue inside this array, it should be put in the new next index of that array. And now I'm going to return true. It should be boolean. Alright, So I have created this enqueue function. Now let's create a dequeue function, and inside the dequeue function return type should be int. Alright, and now let's get an item by, now for dequeuing we will use this variable. It will handle the index of the array, index that will point to the array where we want to dequeue the item. So I'm gonna use front. Alright, and once the item is dequeued, total should be decremented. Alright, and front should be incremented as well, because whenever we want to dequeue an item, if let's say if it is pointing to the 0th index and the next item is at the first index, whenever we want to dequeue the item, it will increment to the next index, so that whenever we want to dequeue the next time, it will dequeue the next item that is on the 1 index but not 0. So it will keep on incrementing as we are dequeuing the items. After that, I'm going to return item. Alright, so we have created our dequeue function, enqueue function. Now it's time to check this queue if it's working pretty fine or not. Inside the main class, I'm going to test that int queue class. So I'm going to make an object of that class. So let's say queue equals to int queue, and I'm going to use the default constructor. Now I'm going to put enqueue and I'm going to put 3. Alright, I'm going to copy this code and I'm going to paste it again below. Alright, let's do it one more time. Let's change its value. So as I mentioned earlier, queue works like FIFO manner, first in first out. So I enqueued 3, so when I need to dequeue it, it should return 3. Now let's dequeue system.out .println, and I'm going to do queue.dequeue. Let's save it, and it was not showing me this thing, so let's dequeue. Right, let's check if the spellings are fine. Yes. So dequeue. So let's copy this line, this. So now the values should be printed in the same sequence as this 3, 4, 6. Alright, let's run it. So you can see that it has printed 3, 4, 6. The value that I enqueued first time, it has been dequeued first. Alright, so now let me show you the problem. Let's say that I have this array, alright, and I have these values. Alright, right now I'm using let me show you. I'm using front variable for fetching the value from that array. Alright, and I'm using rear to enter the value. Let's we have a case that we have a fear pointing to this. Alright, and I have a rear pointing to this as well. Alright, so if the front is pointing to this, means I have fetched all these values, I have dequeued all these values. Alright, and after that I want to enqueue another value. So these values have been dequeued, it shouldn't be here. Alright, so the array is not filled, there is only one item right here, and these first 3 items have been dequeued because our front is pointing to this. Alright, so how can we generate an algorithm that the next value that we want to enqueue should be in the 0th index once it reaches to the last index? I'm gonna do that by just adding one more line inside it. Alright, rather than adding rear plus plus, I'm gonna add, there is an function. I can write rear equals to rear plus 1 mod size. Alright, so it's gonna automatically bring that pointer to the first index when it reaches to the last value, whether it comes to the front or rear. So in the same case, rather than adding the front, I'm going to add front equals to front plus 1. Let's add the brackets, mod size. Alright, so it will work pretty well. Once the pointer reaches to the last index, whether it's front or rear, it's gonna work unlimitedly unless the size of array filled with all the values. Alright, so right now I'm gonna add a new function so that I may let you know that we can add as much functions as we want, because we are creating our custom class. We want to design it in a way based on our requirements. Alright, so let's add a new function. Let's say I want to fetch all the values of this array. Alright, using this function. So I'm gonna write public void show all. Alright, it's gonna print all the values from this array. So I'm going to get the front. Alright, I'm going to get the pointer that is indexing to the front, and now I need to check if total equals to 0. Let's add not equals to 0, and I'm going to write a loop int I equals to 0, I is less than total, and I plus plus. Alright, inside this loop I'm going to print the value system.out.println, and let's add a space before and using the variable q, that is an array, and using the f. Alright, and after that I'm going to increment the front index to the next, whether if it's the last index, it's going to point to the 0th index. So I'm going to write f plus 1, same formula that I used up. Alright, so equals to size. Alright, let's go to the main. So rather than using these things, alright, I'm going to call show all. It's giving me error because this function is not returning anything, it's a void. Alright, so I just need to call this function rather than printing it out, because that function is printing the values inside it. Alright, so we don't need to reprint again. So let's run it. So you can see that the same output. Alright, so it's working pretty well. Next we are gonna use this queue with the help of person object, because in real world we don't use primitive types, we use the object students, person, employees, car. So I'm gonna use the same person class for working with the queue. So let's do that. So I'm gonna be using the same class that I used with stack. This is the person class, and same attributes, same constructor, and same toString function. So let's add a new class, and I'm gonna call it person queue. Alright, and I just want to modify this code. So let's copy this one and paste it right here. So let's modify it according to the person class. Right now it's using int queue array. Alright, but I want this to work with person queue. Alright, so let's change it to person. Let's copy it and change the constructor names as well, because the class name should be equals to the file name. Alright, so that's why let's change it to person. Alright, change person here as well, and here as well. right here. Alright, so let's modify right here. Right now the item is of integer type. Let's change it to person. Alright, because the array is of type person, so that's pretty well. Now let's come right here, and it is of int type. Let's change it to person as well. It's giving me error because can't convert from person to int. Actually I need it to do right here as well. Alright, so error is gone. So I think so far so good. Alright, it will not work right here like this because I'm printing out the values inside it. Alright, right now Q is of person type, so I'm printing out the each object address. Alright, rather than printing it, let's call it toString. Alright, so it's gonna call this function and it's gonna print this line, the name and roll number of individual object. Alright, so it will work fine. So we have modified over Q. Now let's go to the main, and I'm gonna comment these lines, and let's create an object of person Q. With the default constructor, and let's copy these lines. No, not actually. So what I'm gonna do is q.nq. Alright, and I'm gonna create a new object of person, and I'm gonna pass my name, roll number. Alright, rather than sending out the primitive types, I'm sending out the objects. Alright, so let's change its name 3 to 1. Alright, and I'm going to use the show all function so that it may show the first object that I enqueued first. So q.showAll. Alright, so let's run it. So you can see that it has called the show all function, and show all function is iterating through individual objects. It's an individual object is gonna call the toString function right here, and it's gonna print out all the values of those attributes inside the person class unless all the objects have been iterated. Alright, so I hope that you have got the idea how to work with Q, how to work with circular queue, how to make unlimited queue inside an array if the array is not filled up with all the values. Alright, so now next we will talk about linked list. It's a kind of difficult but a very important topic. You must know it because without linked list you can't make your program much better and much efficient. So let's go. There are many types of linked list: singly linked list, doubly linked list, linked list sorting, and I'm also going to be talking about what is the benefit of using linked list rather than array. So let's go and do what is linked list. So first I will talk about singly linked list, and I'll be showing you how to use singly linked list with integer types. Then I will go into advanced topic of linked list. So before writing code, let me show you the graphical representation of linked list. So what is linked list? Linked list is defined as the link between different objects, different nodes of a class, and that class have two properties. One is a value, and other property is gonna take the address of its next node. So let me show you. Let's say that we have a key, let's say it's a head, alright, and it's containing the address 0, and it is pointing to a node, and node have two blocks. You can say that block are the different attributes of the class, alright, and the name of class is node. So I have 2 as a value, alright, and right now this block of node is gonna take the address of its next node. Right now, let's say that the address of this node is 0. Alright, so the head is gonna take the address of the first node of this list. Let's create another node. Alright, its address is 1. Alright, and it has a value 4. So this block is gonna take the address of this node. Alright, and same goes till the end. The last node, the second block of the last node contains null, or it can contain 0 if we have integer type nodes. Alright, but mainly we have a null because we keep the type of the class. Okay, so this is the singly linked list. Singly linked list means that the previous node contains the address of its next node, but not the next node contains the address of its previous node. Alright, so the same goes all the way up to how many nodes we want to create. So what is the difference between array and the linked list? In array, we define the size, that this should be the size of array, this should be the type of the array. And once we define an array and initialize that array, we can't change its size. If we have defined the 10 indices of the array, then we can't extend its size, or we can't decrease its size. In linked list, it automatically keeps on incrementing its size based on how many values we want to enter. If we want 2 students, it will create 2 nodes. If we want 100 students, it will create 100 nodes. Alright, so if we want to remove something from a list, it's gonna automatically remove that node from a linked list. In array, if we need 40 students and we have created the 100 size of the array, then the 60th index, 60 indices of the array are wasted. Alright, it's gonna take space in the RAM. It's gonna take space and it's a really headache. So it's very efficient that everything that we want from linked list to store, it's only gonna store and reserve that much space in the RAM. Alright, so I hope that you have got the idea. So the head is gonna take the address of this first node, and the first node is going to take the address of its second node, and second node is going to take the address of its third node, and so on. Alright, so I'll talk later further that we can have a tail for getting the reference to the last node, but right now just keep in mind that we have a head and we have the key to the first node, and then we can move anywhere we want in the list. So now let's write the code for it, for the integer types. So inside the Eclipse, as usual, I have created this project linked list, and I have this main Java file. I'm not gonna write anything in main Java file, but before that, let's create a new class and name it as int linked list. Alright, so let's finish it. So first of all, it has a property. We have understood that we must have one property of the class, that is a head. That's gonna create and take the address of the first node. So that should be the global property of the class. Alright, so private, actually it should be small, private, and I'm gonna take head. Alright, I'm gonna be using the nested classes in this tutorial because we know that this node is only gonna work within this linked list. It doesn't have anything to do outside the linked list class. So anything that is only required within that thing should only be created within thing. Alright, so this node class should only be used inside this class. So what I'm gonna do is I'm gonna create a child class inside this parent class. So I'm gonna name it node. Alright, this is the child class of this parent class. Okay, so what's this class is gonna take? This class is gonna have two properties. One is the value, alright, that I showed you. This is the total object of that node class, and this is the value, alright, and this is gonna take the address of its next node. So what should be the type of this value? The type of this value should be node itself, because this can only contain the value address of this whole node if its type is node, alright, or if it's parent class. So right now we don't have we are not using polymorphism, so we are going to use the same node link, alright. So the type of this link is node, because this link is gonna take the address of this itself of another object, alright. So we have created a nested node class, and I have defined this node data type right here and the head, so that this head is going to take the address of the first object of this node class, alright. So that's it for now. Let's go and create the constructor for our int linked list class. So public int linked list. Alright, so let's instantiate the head object. Head equals to the new node. Alright, so we have instantiated the head object with the node constructor. We have not defined the constructor for the node because Java automatically creates the default constructor. Alright, so empty constructor is automatically created. Now what I'm gonna do is I'm not gonna create a default constructor. Instead, I'm going to send it an item. This is whenever we want to instantiate the object of this class, we will call this constructor, and we will send the first value, and whenever the first constructor will be called, this first node will be created automatically. Later on I'll show you that how to avoid this problem, how to create the empty node while calling the constructor, alright, so that we may not be restricted to create at least one node while creating the object of this int linked list class. Alright, so I've sent the item. Now head dot, it has two properties, value, and I'm gonna store the value right this. So this is the first node as well as the last node, because we haven't created more nodes. So we have head dot link equals to null. Alright, because it's not gonna referring to any other node, so it's gonna take null. Alright, so right now we have a head, and let's remove it, and I'm gonna create a new graphical representation so that you may understand what's going to happen. So this is the node that we have created for the constructor. Let's say we have sent 2 right here, and we have set this to null. Alright, and this head containing the address of this node. Let's say its address is 1011, so it's gonna take 1011. So right now we have created this much list by calling our constructor. Alright, so next I'm gonna create a function to insert a new node inside the linked list. Alright, so there are two ways we can add a node inside the linked list. One is at the start of list, and other is at the end of list. Let's say we have 5 nodes right here. The first is taking the reference of the second node and so on. And whenever we want to add a 6th node, whether it's gonna come right here or it's gonna come after at last of that list. So first I'll show you how to put any node right here, and that's gonna take the reference of the previous first node of the list. Alright, so let's go and write code first, then I'm gonna redraw this illustration, and let's come and create a new function. So I'm gonna write public boolean insert insert item. So I'm gonna send an item. So what we need first, we want to create a new node, because whenever we want to insert an item, it requires a new node. Alright, so I'm gonna create a new node, n equals to the new node. Alright, so I need to create a node at the start of list. So what I'm gonna do is I'm gonna put the value that I have sent. Alright, and what I'm gonna do is, let's say we have this node right here. Alright, and it has item, let's say 4, and this block of this node should contain the address of this node, because this node should come at first of this list. So it's gonna shift this node to the last of that list. So this block of code should contain the address of this node. Alright, and this node should be given, the address of this node should be given to the header of our list. Let's say we have 111 address of it. So what I'm gonna do is I'm going to take the address of this node from this head, alright, and store it in the link of this node. Alright, so that it's gonna take the address of this node. Alright, so what I'm gonna do is I have stored its value, and I'm gonna write n.link equals to head. Alright, so you see that, let's go. So you see that I have taken, head was taking the address of this node, so I have stored the address of head that it was creating, it was containing, and store it inside this second block of our new node. Now what we want to do next, we want to store the address of this node to header. Alright, so how can we do it? We can do it like head equals to n and return true. Alright, so we have inserted a new node. Now the new shape of this node is like, it's gonna cross this up and it's gonna refer to this node, and this node is creating the reference and storing the address of this node. Now this node has become the last of this list. So the next node that we will be creating with the help of that function is gonna come before this node. Alright, so all the nodes will be shifted to the right side, and the new node is gonna take its space right here just after the header. Alright, so this is the one way that we can put a node just after the header. Alright, so make sure you follow the same sequence. If you write this line before this, it's not gonna work. Alright, so it's up to you to think that why it shouldn't work if we write this line before this line. Alright, if we do it, then it's gonna create so many problems. Alright, so now we have created this function. Now let's go and create a new function, delete node. Alright, delete node is a bit difficult, but I'll write that function at last. Let's first write a function that's gonna print all the items of the list. Alright, so how can we print all the items of this list? We can print, let's get the address of the first node, and the address of first node is stored in the head. So we can ask our header that give us the address of our first node, so that we can iterate through whole list till the end, till the last node. Okay, so let's get the reference from the head, and now I can write while z not equals to null. Alright, so what is z? The last node, the second block of last node is gonna take null in its second block. So I need to iterate with the help of loop that iterate through the whole list unless you are gonna look at this null. Alright, so inside this while loop I can print line z dot value. Alright, and after printing it I need to pass this reference, the address of this node, to the next node. Alright, so z equals to the z dot link. Now the z will be creating the address of its next node. Next time the while will keep on executing, keep on iterating through whole list. Alright, so before writing any other function, let's check out if it works. Alright, so let's go to main and I'm gonna create an object int linked list equals to the int linked list. Alright, and I'm gonna send an item at start. Alright, so now I have sent an item. Now with the help of list I'm gonna insert an item, let's say 5. Let's add another item, let's say 8, and now I'm gonna call the print list. Alright, so now let's run it. So you can see that it has printed 8, 5, 2. It has printed in reverse order because we have seen by doing this illustration that the last node will reserve its space at the start of list. Alright, so anything that we have inserted at first, it's gonna shift it to the right side and that will become last. Alright, so the first will become 8 because that was added at last, and then after 5 and then 2. Alright, so our linked list is working perfectly. Make sure that we didn't needed to create the size of list. It's automatically gonna reserve that much space for 3 different items inside the RAM. Alright, so now let's go and write a new, we can write any function that we want that work with linked list. Alright, so let's go and write our delete function. It's gonna be a bit lengthy. What I can do with the delete function is that I can get the reference of 2 nodes. One is this node and one is the very next node, the first node and the second node, and then I'll be keep on iterating through the whole list where I find this item. Alright, and wherever I find this item I have the reference of its previous node, and then I'm gonna store the address of its next node to this node. Alright, when this will let's create another list. I think you are gonna be confused, so okay, so let's assume that we have find the item inside this node. Alright, so we are gonna storing the reference to this node and this node as well. So if we find that item in this node, then this block is gonna take the address of this node. In order to delete this node, we are gonna remove this reference and we are gonna store the address of this node to this block. Alright, when this block will contain the address of this node will be automatically deleted. Alright, so this way we can delete nodes inside the linked list. Alright, so now let's go and write the function delete. Alright, so now let's go boolean delete item. Alright, and I'm gonna send that which item I want to delete. Okay, so let's first check. We don't need to iterate through the whole list. Let's say that we find the item at the first node, then we can just return that this is the item that we have found at the first node. So if head dot value equals to the item, so we are testing if our value actually exists in the first node or not. Then we can store the reference of second node in the header, then the first node will be automatically deleted. So how can we store? We can get the address of second node with the help of first node. So I can write head.link. Head.link means go to the head and it's referring to the first node, and go to the link of first node. The link of first node containing the address of second node. So now the head is containing the address of second node. Alright, then I'm gonna return true. Else, if we don't find a key inside the first node, then we need to iterate through whole list. So what we can do is, as I have shown you, that we can get the reference of first node and second node, two nodes. The second node will be detecting the value if it's found or not, and first node it's gonna remove that. So head.link while true. Alright, that's the logic that I'm creating. If you're feeling uncomfortable, I know that it's very difficult topic for beginners to grab at first. When I learned it first time, I wrote this whole class for 5 or 6 times by my own without looking at any code. So make sure once you complete this class, you write this class again and again, so to grab the idea that what's going on, and try to change a bit things to work. Alright, I know that everybody of you must be facing problems, and it must be giving you more confusion at first. Alright, so now let's work with the while loop while deleting. Alright, so I'm gonna check if y equals to null or y.value equals to item, then break. When the y will be equal to null, when we are reached to the last node of the list, then it will become null. Alright, when it will become null means that we haven't found any value inside the list. It might be the case that we have sent an item that is not found in the list. So I have added the check right here. Now again I have added a check if we have found the item inside the list. When the y.value equals to the item, even then I'm breaking, and outside this loop I'm gonna check if the y was null or not, then I'm just proceed further. So let's go and write else, and when there is no null and value is not found, then we are gonna keep on iterating through next node. So the y, so I'm gonna store the y to the x, so that x will contain the address of next node, and y is gonna store the address of its next node. Alright, so earlier x was referring to first node, y was referring to second node. Now x is referring to second node and y is referring to third node, and this gonna keep on working unless we don't find a value inside our list. Now we are done with the while loop, and outside this loop I'm gonna check if y not equals to null. Means if y not equals to null means we have found the value, and if we have found the value, and I'm gonna store the address of link of y to the address of link of x, so that it's gonna remove the middle node between these two things. Alright, so after that let's return true. So because we have deleted, else I'm gonna return false. Alright, so we have written this delete function. It must be confusing for you people. Make sure you dry run this code on the notebook, just like I'm doing it on this page, just to illustrate you and explaining you as much as I can. Alright, so now let's check this out if it's working fine or not. You can see that. Let's try to delete 5. Alright, so I have printed these codes, and after that let's call link dot not link, it's list dot it's not showing me the help, So delete item, and I'm gonna send it 5. Alright, and now I'm gonna print list again. Okay, so let's run it. So you can see that first it printed 852, and after that I deleted 5, and then I recalled print list function from that class, and it has printed 82, means we have successfully deleted the node from that list. So our code of delete is working perfectly. Alright, so I don't think that we are gonna write any function, but we can write any function that we want that works. We can write sorting function if we want to sort that I'm gonna do in the coming time. But before that, I want to convert this list and work it with the objects rather than these primitive integer types. Alright, so there are two things right now that I want to show you before further working with this list with the objects with our person class. One thing is that we have seen that whenever we need to call a constructor, we need to send an item, the first item. What if we don't want to create the first node? We don't want to in the arrays we initialize the array, but we don't put the first item while initializing the array. So whenever we want to create an object of this list, the first node shouldn't contain any value. Whenever we want to create the value, we should only do it with this function. So what we can do is we can modify it in a way. Let's say that I'm not sending out anything right here. Instead, I'm gonna send 0. Alright, so it's a value actually, but this is not what we have actually sent right here. Alright, so this is the first node is created, but we haven't sent any value. If we are working with objects, then overall this will be the object type. Alright, and this will also contain null, because objects contain null but not primitive integer or decimal type values. Alright, and now if we want to iterate through all the values, we don't want to print 0. We also need to modify our print code right here. Instead of getting the address of the first node, I'm gonna getting the address of the second node, because the first node is creating the default value that is not the actual value that we have inserted. So I'm gonna take and I'm gonna get the address of the second node by calling the head.link. It's gonna call the address of the second node with the help of the second block of first node and store that address in Z. Alright, so it's gonna work fine right now. Alright, so again, while deleting, rather than head dot value, we can check it with the first node head dot link dot value. It's gonna store the reference of the second node and it's gonna check it with the value. Alright, so it's gonna, rather than deleting it, I'm going to be head dot link equals to head dot link. Alright, so it's gonna work fine because I need to neglect the first node while deleting anything from here. But we can also do it with the previous code right here. It will also work pretty well. Alright, but if we want to neglect that first node, it will that code will also be working, but the speed will be more faster with that updated code. Okay, so next thing that I want to show you, that I have told you that we are inserting node at the start of list. What if we want to insert node at the end of list? How can we do it? In order to do that, I'm gonna comment this code, alright, so that it we keep this code right here, and I'm gonna write a new code for inserting node at the last of list. So what we can do is we can iterate through the whole list till the end of this node, and we're gonna take the reference of the last node of the list, because whenever we are reached to the last node, even then we can store the new node in the last of the list. So what I'm gonna do is I'm going to first create a new node. Alright, and this new node alright, this new node is gonna take the address from head. Alright, and once it gets the reference of the first node, we need to iterate till the end of the node, unless we don't we find the null. Alright, because the last node automatically contains null if it is not referring to any new node. So I'm gonna write if new node dot link not equals to null, then keep on iterating. New node equals to new node dot link. Alright, and when this loop will end, new node will contain the address of the last node of the list. Okay, so what I'm gonna do is I'm going to actually, this was to, let's remove that up, and I'm going to uncomment this line, because this is the n is the node that will be used for creating the new node, and this new node was added right here to contain the reference of the last node. Alright, so what I'm gonna do is first I need to put the value item in the n node. Alright, and then I'm going to store n dot link is gonna null, because this is going to be the last node, and the last node, the second block of last node must contain null. Alright, so now the last node, the second block of last node should contain the address of this new node. Alright, so this variable is containing the address of last node, so this dot link equals to n, because we want to store the address of n in the link of last node. Alright, and then I'm gonna return true. Okay, so now let's go, let's remove this, and let's remove this line. So earlier we were adding the items at the start of list, and the printing order was 852. Let's add another right here, because we updated our constructor. Previous output was 852. Now we have added and updated our insert item, so that new node is added at the last. Now let's run it, and you can see that it has printed the values at the same sequence as I am adding the items in the linked list, because we added 2 and the second node was added at the last of list, the 8 was added at the last of that list. So our code is working fine. Now just to show you that how you can write a complex logic with the help of these lists by using dot link, dot value, different calling properties of this node class. So I'm gonna write a function that's gonna sort the list items. The logic that I'm gonna use in this tutorial is I'm not gonna shift individual nodes right or left. Instead, I'm going to shift the values of the nodes that is in that list. Alright, so I'm going to write a function, and that is going to sort that list out. Alright, so the name of that function would be sort list. Alright, so the algorithm that I'm going to use for sorting the list, I hope that you have already done insertion sort, bubble sort, selection sort. So I'm going to use bubble sort algorithm for sorting the items, the data inside that list. Alright, if you don't know what is bubble sort, that you must have done in arrays in the basic programming courses. If you don't have done, make sure you check that out and learn that thing first. Alright, so what I'm gonna do is in bubble sort, let's say we have let's get the reference of our node. So I'm gonna write node A equals to head dot link. Alright, now I need to write two nested loops. One is going to sort individual item in the list, and the child loop is going to iterate through whole list for sorting out one item in the list. That's the algorithm for the bubble sort. So I'm gonna write while a dot link not equals to null, alright, I'm going to create a new node object, and that's gonna take the address of the same node that A is containing, and inside this I'm going to write another while loop, and this object that the variable B is also going to iterate through till the end of list for sorting out one individual item in the list. And in here I'm going to, let's add the link. Alright, and inside this while loop I'm going to check if B dot value is less than B dot link dot value. Alright, I'm sorting this out in descending order. If you want to do it in ascending order, we can write greater than. Alright, so now at the top let's define a variable int c equals to 0, because I need to swap the values, and for swapping I need a third variable. So I'm gonna take c equals to b dot value. I have stored the value of B node second block, and now I need to value equals to B dot link dot value, and now I can get like B dot next B dot link dot value equals to C. So I have swapped out the values. Alright, and after this if I need to send this B, the address of the second block of B, to the next node. So I can write B equals to B dot link. Actually I'm used to next because I have written link, so I need to write a link rather than adding next. So outside this while loop I need to shift the reference of a variable to its next node, so I can write a equals to the a dot link. Alright, so we have written the algorithm for the bubble sort with the help of linked list. Now let's go and check this out if it works perfect or not. Right now we have listed out the items because our each node is being added at the last of list, so it's already sorted in the ascending order. Now let's shuffle this out. I'm going to cut this line and paste it right here. Alright, so it's gonna sort out in descending order, so the output should be 8, 5 and 2. Alright, so let's run this up, and you can see that it has printed in the same sequence because I haven't called the sort list function yet. Now I'm gonna call the sort list function. So sort list, so I have called the sort list. Now I'm gonna again call let's add a breakpoint so that the output should be printed on the next line, shouldn't be merged. So I'm gonna write list dot print list. Alright, so the next values should be printed like 852. Okay, so our list, the items in the list have been sorted out in descending order. Alright, so our sort function works perfectly as we want it. So I hope that you have understood. It's pretty complex logic, pretty complex algorithm. It's easy to understand if we are sorting and applying the bubble sort algorithm on arrays, but it's not so easy. Make sure you dry run this code and write it as much as you want on your notebook and then on your PC again and again to get the better understanding of this code. So that's been done for the primitive types. Now let's go and update this code for working with the objects rather than the primitive types. Now I'm going to use the same person class that I used with stack and queue. It has the same roll number and name properties, and I'm going to use it and create a new file, and I'm going to name it person linked list. Alright, and now I'm going to copy this code from the int linked list to the person linked list, and I'm going to update this code. Let's remove that thing up. Alright, let's modify it. The name of file and the class name should be same, linked list. Let's start from the bottom. I need to change this class because the node, the first block of node should be of person types. It's not the int type. So I'm going to change it from person, from int to person. And the second one is the link that will contain the reference of itself, of another object of the same type. Alright, now let's go at the top, and the value head dot person equals to person. I'm not going to create a dummy node that I showed you earlier, but I'm going to send out a person while constructing the object of person linked list. Alright, you can do that as well. You can send nothing and you can get the set the person value to the null and the link to the null as well. Alright, so you can do that as well, but I'm going to send out the first person object while constructing the object. Alright, so now let's go and change and update this a bit. We need to send out the person. Alright, so again we are gonna store the new node at the last of list. Alright, so n dot person equals to person. Alright, and the last node should contain the null in its second block, and its link is this, and the so far so good. Now let's come to the print, and we can see that we have a person dot toString. Alright, so we are gonna print out this whole line of code. It's gonna print the name and roll number of our person object. Alright, so for deleting it, we can use the name of that person for deleting and detecting if it actually exists in the list or not. So rather than setting out head.value, we can use let's send out the name, string name, and inside this if I can write name dot equals to check the equality among strings. We can write head dot person dot we haven't defined. Let's define the getter for the name. So I'm gonna write string get name. Alright, so I'm gonna return this dot name. Alright, so now I'm going to call that function person dot get name. Alright, if this matches, then we can execute these two lines of code. Else, this is the code when we are intending to find the name in the first node. If it doesn't exist, then we are going to run this else code. Alright, so inside the else, we're going to check if while let's change it a bit. So rather than adding the if, I'm going to copy this code and paste it in while, and in here I'm going to check if y is not equals to null and not y dot person dot get name, because we need to check it with the name. Get name dot equals, and inside it I'm gonna send out the name. Alright, and inside the while block we are gonna pass the nodes to the next nodes. So I'm gonna write x equals to y and y equals to y dot link. Alright, and after that inside the if, I'm gonna check if y not equals to null, then I'm gonna send that to the next thing. Alright, so for sorting out, I'm not gonna do it right here. You can do it yourself, because to sort out string, it's not so easy. It's easy to sort out the integer values. You can use your own algorithms that how you want to sort strings, while you can sort it alphabetically, or you can sort it lengthwise, the length of the name, or anything you want. But you can use the same algorithm for sorting this out. For now, I'm gonna comment this code. Alright, so far so good. Now we need to go to the main and check this out if it's working fine or not. So I'm going to comment this code, and let's create an object of person. Person1 equals to the person, and I'm gonna send out my name, roll number, and I'm gonna copy this line and paste it again. Alright, so I think that two objects are enough. Now I need to create an object. So let's copy this line, paste it, and I'm gonna send person1. It's not int linked list, it's the person linked list. Alright, so I've sent out person1. Now I need to insert a new item inside it. So list dot insert item person2. Alright, so we know that we are inserting new nodes at the last of list. So person2 should be at the last and person1 should be at the first node of the list. So now I'm going to print the list. So let's see if it's working fine or not. So let's say that it's print list. Alright, so let's run it and check this out. So it has printed Ali, but it has not printed out. Let's see that where is the problem. it created the new node, and in the first node, actually we need to change this a bit. Where is it? Actually we need to store the address of first node rather than the second node. We did that because we created the dummy list in our int linked list. Now let's go and run it again. You can see that it has printed out the first item that we entered, and then the second one that we added at the last time. Alright, so our linked list class is working perfectly with the help of person class as an object. So we know that what we have learned that how we can write our custom class for linked list, for integer type, for primitive types, for the objects. Alright, so we are done with our linked list. Next we will move towards more advanced concepts of data structures. Now let's talk about doubly linked list. I have already explained you what is singly linked list, and I have given you different examples that how singly linked list can be coded. Now this is a bit advanced version of linked list that is called doubly linked list. So let's see in diagram that what is doubly linked list. Let's say that we have a head, and as usual head contains the address of node. Alright, but in doubly linked list we have 3 blocks in one node. The middle block or any one block contains the value, and the next block contains the address of its next node, and the previous block contains the address of its previous node. Right now this is the first node, so the next node and the previous node will contain null. Alright, so let me give you an example by just illustrating. Let's say that the previous node contains null, alright, and it contains the address of its next node. It has 3 blocks again. It contains the address of its next node. Let's say that we have the address 101, 102. These are the address of these nodes inside the RAM. Alright, so it has 3 blocks. Alright, and this contains null because it doesn't have any previous node, and it contains 102, that is the address of next node, and it contains 101, this is the address of its previous node. Alright, and it contains, let's say, a value 2, and this is the next, and it's gonna take the address of its next node. So address is 103, and it's contained the address 102 because this is the address of this node. It contains the value, and the last node will contain null because it doesn't have anything after this node. So this is how doubly linked list is illustrated. This is how doubly linked list is defined. Alright, so there are many examples that I can show you, but I will first show you how to write linked list, doubly linked list code with integer types. So now let's go and write the code, and actually I will modify the previous code that I have given you in singly linked list. So right now I have created this empty doubly linked list project, and inside it I have just main file. Alright, and now I'm gonna create a new class, and I'm gonna call it dlist. Alright, and I'm gonna finish it. So I'm gonna open this previous int linked list class. Alright, and I'm gonna copy it and paste it right here. Alright, let me close the previous project. Alright, and I'm going to modify this class in such a way that it will work as a doubly linked list. Alright, first I need to change the name of class same as the name of file, and the constructor as well. Alright, and let me remove this code. I don't want to sort doubly linked list. And so now first I'm going to modify this node class, the node nested class. Right now I have this node class, and this contains two properties, means the object of this class will have two blocks, but in doubly linked list we must have three blocks, as we have seen right here. Alright, so we need to have three blocks. So I'm gonna create a block node that will have the address of its previous node, and let me change the name of variable to next. Alright, so this is how the doubly linked list work. It has a previous node type variable, the value int type variable, and the next node type variable. Alright, so we have modified our node class. Now let's go and modify this a bit. Let's say that I'm not going to create the dummy linked list, because in order to construct the object of this class we must send a value so that it may create and initialize the first node at the start of its construction. Alright, so I'm going to send value item. Alright, and I have instantiated the node and stored the address of this node inside this head variable. Alright, that is of the same type. Okay, and I have sent it an item, so I need to send an item, and next equals to null, and previous equals to null as well, dot prev. Alright, the first node doesn't have any previous node, it doesn't have any next node, so that's why I have given the value null to both the properties of this node class. Alright, so now let me change this a bit. Right, I have changed the name of variable link to next, so I'm going to replace the link with next everywhere. Alright, this is the delete function. So it's giving me error because I need to return something. Let me return true. Now I need to write a code right here in order to insert an item. Alright, before writing code, I just want to let you know that there is a different way that we add a value, add a node inside the doubly linked list. Alright, so let me remove this first, and I'm going to show you that how the doubly linked list will be worked. Okay, so let's say that I have this head, alright, and I have this node right here. Alright, and I have this node. Let's assume that we already have these much nodes right here. It has a null, it has the previous, it has the null as well. Alright, let's add 2, 4, it has the address 102, 103, it has the address of its previous node, it has the address of its next node. Alright, so the insertion type that I'm going to do in this tutorial is I will insert a new node at the start of this list. Alright, not the end of this list, and I'm just going to show you the start of list. I have already shown you how to add a node at the last in singly linked list. It's your assignment, it's your task that you understand this and write a code so that you may be able to insert the node at the end of list. Alright, so now let's say that we want to add a new node. We have created a new node. First we need to create a new node in order to insert. Whenever we will call this function and send an item, what we will do is we will create a new node. Alright, and after that we will enter a value inside it. So I'm going to send it an item. Alright, this is the first step. Make sure you write it down, item, first item. Alright, and after that I'm going to set its, because we are adding this node at the start of list, so I'm going to set its previous to null because it will not have any previous node before this node. This is the second step. And the third step that I will do is I will set the previous of already added node to this new node that we have created. Alright, so I'm going to, let me remove this null, and I'm going to add a value. Let's say that we have the address 101 of this node, and I'm going to set it 101. So it's gonna take the address of this new node. Alright, this is the third step. And the fourth step is I'm going to set the next of this node 102, and it's going to take the address of this node. Alright, right now this contains the address of this node, this contains the address of this node, but the head contains the address of previously added node. We need to give the address of our newly added node to the head. So we will remove the address from here and we will set the address of newly node to head. Alright, so these are the steps that you need to work on, and it will work pretty well. Now let's write the code for it. First we needed to create the object of node. Alright, and after that we need to set the value to the item. Now we need to set the previous of this new node to null. Alright, so n.previous equals to null. And the fourth step is we need to set the previous of already added first node to this new node. So head.previous equals to n. Alright, and after that we need to take the address from head and set that address to the next of our new node. And lastly, we need to take the address of head and set it to our new node. Alright, make sure you follow the same step. If you write this line before this line, it will not work pretty well as it is expected. Alright, so rest of the things are pretty fine. Delete will work as it was working earlier in singly linked list. So let's go and check this out if it works. So I'm going to write delist list new delist and I'm going to send it to. And after that let's insert few items. Let's add 3, insert 6, and after that let's print these values. This is the print function. Alright, so now let's run it. So you can see that these values have been printed because I am inserting node at the start of list, so that's why the 6 is printed first and 3 then 2. Alright, now let's go and check this out if the delete works well, but let's add a breakpoint, line break first. Alright, so I'm going to delete item. Let's say we want to delete 3. Alright, and after that let's print list. Let's check out if the function name is same, delete item and the print list. Alright, now let's run it. So you can see that it has deleted 3 and it has printed 6 and 2. So our delete is working pretty well, and our insert function is also working well. Print is also working pretty fine. So I hope that you've got the idea how to work with doubly linked list. There are different bunch of other types of linked list as well. Let's say that previously I was inserting items at the start of list, at the last of singly linked list. So I was iterating through the end of list, and when I was reaching to the last node, then I was inserting that new item. One way to do that is to add a reference of the last list, same as we add the reference of first list. Alright, and the last node called tail. Alright, this contains the address of last node, and this head contains the address of first node. Whenever we want to add an item at the last, we can use this tail. Whenever we want to add an item at start, we can use this head. If the list becomes so large and if we start iterating through this list while inserting the items without this tail reference, it will take a lot of time. Because we need to iterate through node by node and then reach to the last of this list and then insert a new node. We can add a tail just like this, and we can set out the algorithm right here so that that tail contains the address of that last node. Alright, and other type of linked list is circular linked list. In circular linked list, the last node contains the address of its first node. Alright, so it will be unlimited. The way that we can print all the items inside this list is that we can check out if the address of head equals to the address that is stored in this block, because this block is storing the address of this node and this node's address is also being stored in head, so these values should be equal. Alright, we can check out if any two values have becomes equal, means that we have reached to the last node and we have printed out all the values of this list. If we don't do it, then it will keep on iterating through the list and it will keep on printing out the values again and again. So this is called the circular linked list. If you want to learn more about linked list, there are a bunch of other types of linked list and different practical examples. One of my favorite book is this one. I just googled this book and I got the first link where I got the PDF. The data structure and algorithm. This is my favorite book written by Robert Leffer, and I'm going to give the link of this book in description below. You can take this book and read it for more learning. If I start writing all the algorithms that are written in this book, then it will take bunch of time, more than 10 hours. Alright, so it's up to you that learn something that you need in your project. Next, using the same algorithms, doubly linked list algorithms, I'm going to start talking about trees. A binary search tree, because that uses two reference variables and one value variables for the value and the reference variables for the left and right children. So now I'm going to talk about tree in data structures. Tree data structure works in various applications in real life, like the Google Map works on trees, like finding the shortest path from one place to other place can be done with the tree data structure, and it has various properties and various types. In this tutorial, I'm going to be talk about binary search tree, and it is used in various applications. So let's talk about what is tree first. So tree has a node that is called a parent, and each node have children. Alright, and this has more children, and this goes as much as we want. Alright, any parent can have more than one child nodes, right? This is the parent and it has two children, 1 and 2, and this one has two more children. Alright, and these nodes are called the grandchildren of this parent node. Alright, and these are the three children of the parent node 2. Right now I'm just talking about the general tree but not the binary search tree. So now let's talk about what is binary search tree that we are going to implement with the code in this tutorial. Alright, so binary search tree have different properties. It has a parent and the parent has some value. Let's say that it has a value 30. Alright, and it has a left child. Left child must be less than or equals to its parent. The value of left child is equal or less than its parent. So it can be 30 or less than 30. Let's say I have set it to 20, and its right child must be greater than its parent. So this is the one property of binary search tree. So it can be 31 or greater. So let's add 35. Alright, and another property of binary search tree is that it has any parent child must have at most two children. Alright, right now the 30th this node, root node, have two children, so it is covering up the property of binary search tree. Now let's have 20 have two more children, so the left child must have the less value and the right child must have the greater value. The children values don't matter if you enter 30 40 right here. Alright, and it becomes greater than its grandparent. Alright, it doesn't create problem. It is still a binary search tree. This property that the right child must be greater than its parent and left child must be less than or equal to its parent only lies within the parent and children, but not the grandparent or the grandchildren. Alright, so these are the properties of binary search tree. Considering these properties, I'm going to implement and write the code and implement this binary search tree. So now let's go. But I'm not going to implement it with the integer data types, but I'm going to implement it with the person actual real world objects. So I have created an object, a class, and it has two properties, name, age, and a constructor with a name and age, and I have the getters and a setter for the age, and I have a toString function to get the name and age in one string. Alright, it's going to return me the whole result that I'm going to construct object with this constructor. Alright, and then I have a main. Now let's go and first create a class, and I'm gonna name it BST, stands for binary search tree. Alright, so I've created a class, and inside this class let's go and just like linked list, I'm going to create a nested class called node, and the node, let's go with that how check this out, how this can be implemented. It will be implemented with a node have three blocks. The middle block will have the value, the left block will contain the address of its left node, alright, and right block will contain the address of its right node. Alright, let's say it's 3, it's 2, considering the properties of binary search tree, and this left block will contain the address of its left node, and this gonna take the address of its. So this goes like this. Alright, so I hope that you have got the idea. So now let's go and create a nested class inside it with a name node. So I'm going to write public class node. Alright, and inside it I'm going to create first let's call it LC, stands for left child, and then I'm going to create a data variable for the person that's going to store the person data, and then I'm going to write another variable RC, stands for right child. Alright, so I have created this node class. Now let's go and create some properties for the BST class. First I need to have a root node, so that when I come to this class I must have access to the root node. Alright, so for the root node I must have a variable called root. Alright, and after that I'm going to create a constructor BST, and inside this constructor I'm just going to set the root to null, because at start I don't want the root node to have the left or right child. I'm going to insert the left or right children with a different function called insert. Alright, so now let's go and create a function. So I'm going to return boolean if the insert. So now let's send an item inside it with the data type person. Alright, it's giving me error, so let's return true. So error removes. Alright, and in here, just like the linked list, what we need to do in order to insert a node, we must need to create a node first. So I'm going to create a node n equals to new node. So now let's go and add the data in it. So I'm going to add n dot data equals to the item. So I have set the data in the node. Now I need to set its left children and right children to null. Alright, so now n dot lc equals to null, because this node is not going to have its left children or right children for now, but this node is going to be the children of that root node, so we don't need its own left or right children. That's why I'm setting out the null to the left children and the right children. So I've set out the values inside the blocks of that node object. Alright, and after that I need to check if the root is null, so if the root is null means that we haven't added any node inside the tree yet. The tree just have a root node, an empty root node. It doesn't have any children. So means that we can directly set this new node as the children of this root node, because it is null means there is no children. So I'm going to set this new node directly to the root node. So I can set root equals to n and I can return true. Alright, what if I have constructed the tree and I have called the insert function and I have sent out the new person object and I have grandchildren and the great grandchildren of this tree of the root node. So I need to iterate through the whole tree unless I get to the last children of that tree. Outside this if, let me write the while loop in order to iterate through the whole tree, and check this out, that we should insert the new node to the left side or the right side based on the name of that person. I'm not using the integer types, I'm using this object. So I'm going to check out considering the property of binary search tree with the name. If the name starts with A and the name starts with B, the A is less than B. So means that the name that starts with A should be on the left side and that is on the B starts with B should be on the right side. So I'm going to check out the greater and equal properties for the binary search tree based on the it's going to be alphabetically. Okay, so now let's first get the reference of root, and I'm going to get the reference as a child as well, because I need to keep on iterating through with the child node and I need to set that new node with the help of that parent node. So I need to get the two reference of that root node. So let's add a while loop, and inside it I'm going to check if C not equals to null, then keep on iterating through the tree unless you get to the last node of that tree. Okay, and after that inside the while loop I'm going to set P equals to C. Alright, and inside it I'm going to check with the if that we should go towards the left side of tree or should we go to the right side of tree, and we can check it with the name of that person. So I'm going to set item dot get name, and Java has a built-in method that we can use to compare the greater or less properties of the name alphabetically. So the compare to returns -1, 0, positive, negative, or 0. Alright, if both are equal then it returns 0. If it is less than 0 then means that the item get name, the item name that we have sent is less than the name that we are checking with. Alright, so I'm going to check it with child c.data.get name, and after this I'm going to check if it returns 0, then we should move towards the left node of that tree, and inside the else we should move towards the right node of that tree. Okay, so far so good. And after the while loop I need to check if item dot get name dot compare to parent dot data dot get name is less than 0. This is going to happen if we reached to the last node, and we reach to the last node we still need to check that if we should go towards the left or the right side. Alright, so that's why I'm doing right here. So I need to check it for parent as well. So for parent p.lc equals to n, and I'm setting out the new node on the left side, and in the else I'm going to set out the new node that I've created with the n variable to the right side. So p.rc equals to n. Alright, and after that I have returned true. So it seems very complex logic. Once you write it by your own, just pause this video, understand it, pick up your notebook and draw it as I am iterating through with this code. Alright, and write it your own self 2-3 more times without looking at this code. Alright, once you look at it, write it down and do it your own self as well. Alright, this is the way of practicing such kind of codes. Alright, so now I have written out the insert function. Alright, and after that let me write the function to print out all the nodes. Alright, so I'm not going to use it with the loops, but I'm going to use the recursion way of iterating through whole tree and printing out the values of this parent of this whole tree. Alright, so if you don't know what is recursion or very weak in recursion, I have already created a tutorial video in which I have explained from the beginner level to the advanced level that how to write recursion based on different problems that we face. So make sure to check out that video if you face any problem in recursion. So let me write a code void show all, and I'm going to send out a node inside it, and that node is going to be the parent node because we need to start iterating through the parent. So I need to first take the reference of that node. Alright, and I've sent this node because it's gonna take care of that from where we're gonna start printing the whole tree. If we're gonna start printing a whole node from the start root node, then we can also check this out. If we want to start from any sub tree of that tree, then we can also print that out. So if p not equals to null, alright, then first print out the value. Alright, and then I'm going to call the same function. Alright, first I will go towards the left side, and then I will go towards the right side once we get to the last children. Alright, so I think that the other functions that I need to write in this class, I'm going to write it later. First I need to check if it's working fine or not. So now let's go to main, and I'm going to create a few person objects. So let's p1 equals to the person, and inside it I need to send name, string type, and an age. Alright, so let me first send Omer, and let me send it 24. Alright, let me create 3-4 more objects. Alright, so I have created these much objects. So let's change these variable names. Alright, now I'm going to use this function in order to insert. First I need to create an object of it, then I need to use this function in order to insert that item. Alright, so now let's go and first bst equals to the bst. So I've created a new object, and with the bst I'm going to use insert function, and I'm going to send p1. Alright, let's copy this code and paste it 4 more times, and I'm going to change its name p2, p3, p4, and p5. Now in order to call the show all function inside this bst class, like we have written this show all function, we need to send out the node, that from which node we need to start iterating and printing out the children and the values of that children. So in order to get that node node we need to create a new function, and we are gonna send the name of that person to that function, and that function is going to return us that particular node where that name will match. Alright, so I'm going to write public node, that's going to be the return type, and the name of function is find node, and I'm going to send out the key inside it. And inside this function again I need to write node c equals to root, and I need to iterate through till the last node, and that's going to be the last child. So again I need to check if key dot compare to c dot data dot get name equals to 0, means it matches. Alright, then I'm going to break it. Okay, and after that I need to set another if key dot compare to c dot data dot get name is less than 0, means we need to go towards the left side. So c will have c.lc. And lastly, if we haven't found any node that is equal to that particular key, or we haven't found any node that is on the left side, then it must be on the right side. So we can simply set the right children to the C. Alright, and outside this while loop I can just return C. Alright, so now let's go to the main and call the show all function, and inside this function let's call bsd.findNode, and let's send out its Adam. Alright, so first it's gonna call this function, and this function is going to send us the particular node that we want to check the children of that node. Alright, and then it's going to be sent with this function. So now let's go and run this out. So you can see that it has printed this node. Alright, so now let's try with different values. I have set out Ali, and let's run it. So you can see that Ali, Adam and John, because this is the top level parent node and this is the left children, this is the right children. Previously I set out Adam because Adam was a children, it didn't have any children inside it. It was the last node in the tree, that's why it just printed Adam. Now let's try and check out with another value, Umair, and let's run it. You can see that Umair was actually at the top node and all the other nodes were the children of that parent node. So that's why it has printed and iterated through all the nodes. So I have sent out, I can send out any node inside it with the value, and it's gonna print out all the children of that particular node. So far so good. Now I think that let me see that if we need to create any function inside it. So let me write another function to check out the parent of any particular node. Alright, just to give you an idea that how the algorithm of tree works. So now inside, let's come right here and I'm going to write node. It's gonna return me that particular node that is the parent of that key that we are gonna send in this function. So I'm going to set find parent and I'm going to send out the key that is going to be the key of children. Alright, so inside it I need to set out the reference of parent, root, and C equals to the root. Alright, and right now I'm not going to use the while loop, but let me show you how you can work with the do while loop as well. You can also write the for loop as well, but that needs some initialization and increment, so we are not going to do that thing. So let's write do, and if key dot compare to c dot data dot get name equals to 0, and inside this if I'm going to break. Alright, and after that I'm going to write and set out p equals to c. Alright, and after that I'm going to add another condition that is going to be compare to c dot data dot get name, if it's check out if it's on the left side or not, and inside this if I'm going to set out the left children, c equals to c dot lc. Alright, and lastly I need to add an else, and inside the else I'm going to set out c dot rc. Alright, so let's add a condition that is a part of do while loop. If c not equals to null, let's add the semicolon. Alright, and after that I'm going to print out let's add these arrows plus p dot data dot get name. Alright, and I need to return something from here as well, so I need to check if c not equals to null. This is because if that particular node that has this key have no parent, then we should return null. Alright, right now it's p, and inside the else we need to return null. Now let's go and check out this function if it's working fine or not, but before that it's going to return me a node. We need to have another function that's going to take this node and return me the data of this node, this data, and with the help of this data we can call the toString function to print the values. Alright, so now let's go, and I'm going to write a new function public. It's going to return me person, so get data, and it's going to take node, and with the help of this node it's going to return me n dot data. Alright, and inside the main with the BST I can call get data, and inside it I'm going to send out that particular node. Alright, but that particular node would be BST dot find parent, and inside it I'm going to send out Adam. Alright, this is going to return me the node, and then this node is going to send to this function, and this function is going to return me the person. So I need to take that person in P object. Alright, so now let's go and print out that particular P dot toString. Alright, so let's run it. So you can see the parent of Adam is this node, Ali, that has age 55. Alright, let's change it and check this out. Let's send Ali, who is the parent of Ali. Let's run it. The parent of Ali is Umair, that has age 24. So it's working perfectly. So I hope that you have got the idea that how these things are being worked with each other, how to write algorithms, how to iterate through the tree, and especially how to write the recursion to print out all the values inside this node. Alright, so next I'm going to talk about the hash tables, and I'm going to make a full-fledged application that's going to use all these concepts that I have been talking in this tutorial. That's going to use linked list, doubly linked list, stack, cube, and hash tables, and we will use all these data structure concepts to build up a small database application, not the actual database but the local database application, just to illustrate you that how these things can be merged together in one application. So now let's go and first talk about what is hash table. So what is hash table? Hash table works with arrays for searching, for adding data inside the arrays. Let's define and create an array to see the practical example of hash table. So I'm gonna create an array 0, 1, 2, 3, 4, and 5. So this array have 6 indices from 0 to 5. If we talk about linear search in array, I hope that you already know that what is linear search. Let's say that we want to search any item that is on any index of this array. Then in linear search we need to add a loop, and inside that loop we need to iterate through each index one by one to check that in which index that value exists. If we want to, let's say that we have 42, we have 51, and all other blocks have other values. We want to find 51. We will start with 0. If check if the 51 exists here, we will start with 1. We will check with second index, and we will find that the 51 exists in the third index of this array. So this is called linear search. If array gets longer, in bigger applications array size gets much longer, like 10,000, 20,000, and we need to apply the search on every value of that array. So it can be very hard, can be very slow for our RAM to process that much data for individual elements. So hash table works and solve the problem of the speed of searching inside an array. What hash table does is it doesn't start from the 0th index or first index, and it doesn't iterate through each index one by one to find out that where that particular element exists inside this array. Alright, in fact it already knows that in which index that value has to be existed. Alright, it add that element in such a way that when it needs to find that element, it already know that this element exists in that particular index, and it goes there and it fetch that particular element from that array. It might be very confusing for you for right now, but let's see an example. Alright, how does it process that particular data and store that data in any particular index? Let's say that we have this array. It has 5 indices from 0, 1, 2, 3, and 4. Alright, and this array is of string type. Let's say that we want to add a, small a. Alright, and what hash table does is it convert that particular value into its ASCII code. If you want to know what is ASCII code, just search on Google. You will find all the ASCII codes of all the characters that are on your keyboard. So anything that is on the keyboard, we can only write those particular characters, and all those characters have its ASCII code. The ASCII code of small a is 97. So what hash table will do is hash table will divide the ASCII code of this number with the length of array. Alright, so the length of array is 5. Alright, and it will take the mod with the 5, and the result of 97 mod 5 is 2. Alright, and anything that it will get out of that mod, it will go to that particular index and it will store that value inside that index. Alright, let's say that we have another value called C. Alright, let's say that we have a value have two characters. Let's say that we have C and D. Okay, so what it will do is it will go and find out the ASCII code of C. The ASCII code of C is 99 and ASCII code of D is 100. Alright, so what it will do is it will add both things and it will take the mod with the length of array, that is 5, and the result of it, it will become 199, so it will become 4. Alright, so it will go to that particular index and it will store that particular value in that index. Alright, so it will keep on processing this data like this way, and it will go to that particular index and store that value in that index, and we're gonna write the whole class that is going to convert and calculate this much data with the hash table class that we are gonna write our custom. Okay, so now let's say that we want to fetch any data from an array. Alright, let's say that we want to find that where A exists. Alright, so now let's say that we send an A to find out that element inside an array. Rather than checking out each index, what we will do is we will do the same process. We will convert it to its ASCII code and we will take the mod of it with the length of array and we will get 2, and we will go to 2 directly without checking other indices. We will directly go to the second index and we will fetch the data that is stored in the second index, and in our case this is A. So this is how we will work with the array, but there is a drawback in this process and there is a solution as well. So let me tell you that what is drawback first. Alright, so let's say that, let me remove this arrow and this thing. Okay, so now let's say that we want to store D and C. Alright, earlier we stored C and D, now we want to store D and C inside this array. What it will do is it will convert D to its ASCII code, that is 100, and it will convert C to its ASCII code, that is 95. Alright, and the mod with 5 is 4. Alright, and it will go to the fourth index and it will store that particular value inside that index. Now it has replaced the previous value in that particular index, so we have lost our previous value. Alright, so you got the drawback of it. Anything that process that particular data, and if the result of that process or result of that calculation is same as it was calculated previously, then it's going to replace that particular value in that index. So this is the problem. Now there are 3 main solutions of it, and I'm going to use one solution in and with that solution I'm going to make that whole project the student database project. Alright, so the first solution is, if we found the same value again, like in our case we found 4 and again we find 4, then what we will do is we will find out the very next index of that array that is empty, that is not filled up. Alright, and we will store that particular value in the next index if the previous index, the calculated index, is filled up. Alright, so any duplication or anything that occurs more than 2 times, or 2 times or more than 2 times, then it will go towards to the next index and it will store to that next index. Okay, but this is not a recommended practice, but this is the one way. The second way that we can do is we can create a 2D array. We can create a let's say that the row of this array is 5 and we create the 5 columns as well, considering that any particular value, any particular index can be generated at most 5 times, so we will create 5 columns right here. Okay, like this. Okay, so what we will do is, if we get any index more than one time, we will store first value and we will match that particular index after calculation with the row number, and we will store the value on that particular index to the 0th column, and anything that occurs second time, we will store the next value that has the same index. We will go to that particular row, alright, and we will check the first column. If it is filled up, we will go to the next column, and if it is empty, then we'll store that value, that is D and C, to the second column. And if we get another value that calculates and outputs the same index, let's say it calculates the 4, and then we will go to the same row number and we will go to the column one by one and check if any particular column is empty. Let's say that the 2 is empty, then we'll go right here and put that particular value inside it. Alright, so this is the second way, but again it's not the appropriate way to do this, because in this way we are just occupying the space in the RAM and we are not using these spaces. So it's consuming RAM without any reason. Alright, anything that is not filled up is occupying the space. So the third way, that is more appropriate, and I will use the third way that I'm just going to explain you by illustrating right here. That is the linked list way to avoid that problem in hash table. Alright, so now let's say that we have an array. Let's say again we have the 5 blocks in the array. So what I'm gonna do is, each block of this array is gonna take the reference to the linked list. Alright, let's say that as I have already explained you what is linked list. Let's say that we want to store A and B. Alright, and the second value, that is B and A, that is going to generate same ASCII, same code with the hash table calculation, and we are going to store it by creating a new node and store that value inside the new node. If we got another value that generates the same hash code, then we will create a new node and we will store that particular value in the new node. The benefit of this way of avoiding that problem is that it's only going to create that much node where there are duplications. It's not going to create extra nodes that is going to remain empty. Alright, so I'm going to implement this way to remove that duplication and to avoid that overriding values that generate the same hash code. Alright, so again, each of these indices of this array is going to take the reference inside it, and it's going to have address of each linked list. Alright, that linked list can be of person object, student object, integer types, double, or any other object. Alright, we are just going to store the address of the whole linked list, actually the first node, address of first node inside this block. Alright, because the first node is going to take the address of second node and we will take along all the way. Alright, so I hope that you have got the idea that what is hash table, how hash table works, how it calculates the formula, and it generates an index and it goes to that index and store that particular value at that particular index. Make sure that hash table only works with arrays. It doesn't work anything without arrays. Java have built-in hash table class that also work on the same calculations, So we are going to create our own custom hash table class based on our own requirement. Alright, so now let's go and create our hash table class and make a full-fledged application with the hash table, linked list. So let's go. So right now I have created this project, and inside this project I have two classes. One is main, and inside the main I have nothing, and I have added another class student. Make sure you pause this video and copy this class as it is written. I have added name, roll number, CGPA as properties, and I have added a constructor that I am using for constructing an object of it by sending name, roll number, and CGPA, and I have setter getters and setters for each of these properties. Alright, so make sure you write this class. It's not very complex because I hope that you already know that what's going on here. And at last I have this toString function that is returning all the values in one string. Okay, so that's been done. Now we need to create another class. For first I will create a class link list class that's going to create the linked list for this student object. Alright, I'm just going to write the code in front of you because I have already explained you that what is linked list, how linked list process. So I'm going to create a class and write it as well. So the name of this class would be student list and finish. Okay, and inside this class, as we have already done, is first what we need to do is we need to create a nested class, and the class will be node. Alright, inside it I need to create two main properties. First one is the student because we want to work with student object, and the second one is the node object. Next. Alright, so we are done with our nested class. Now let's go, and inside this class, as we have already done, is we need to create a node that has the reference of the first node inside the list, and inside the constructor std list I'm going to create a dummy object. Alright, so h dot next equals to null, h dot data equals to null. Alright, because I don't want to put a data at start of constructing an object of this class. Alright, I want to use the insert function for adding up the data. So I'm going to write insert std, and I'm going to send out student std, and inside this function let's first return true to remove the error. Alright, and right here as usual we need a node. Alright, let's set the data std. Alright, and then we need to set the next of new node with the next of first node. Alright, and then we need to set the next of header to the n. Alright, this node will be inserted after that dummy node, because dummy node is nothing. We need to start adding node after that dummy node. Okay, so now we are done with our insert std function. We need to create few more functions for working with hash tables. So as we are working with the student, we need to create functions like if any particular student already existed in the list or not. Alright, so we need to create a function. Let's say that we have a boolean have roll number string. We are going to send the roll number. Alright, we are going to work with hash tables by converting that roll number into a hash code, and we'll store that student object based on the code that is generated with the roll number. I'm not going to use the name of student because name can be same, roll number will always be different. So I'm going to use roll number for inserting and converting it into hash code. Alright, so I need to check if the roll number already existed in the list or not. Alright, so let's first get the reference h.next and boolean have equals to false. Let's add and a while loop a not equals to null, then keep on checking if that value exists or not. So if roll number dot equals, this is the way we can check string in Java. We shouldn't use double equal, that is only be used for primitive types. In strings we use equals method to check the equality of strings. So I will use a dot data dot get roll number. Alright, and inside this if I'm going to set have true. Alright, and after this if the value doesn't exist in that particular node, then I need to go to the next node. So a equals to the a dot next. Okay, so outside this while loop I'm going to return have. If we find the value, then it's going to have true. If we don't find, it's going to remain false. Alright, so this function is going to be used for checking the particular student in that object, in that list. Alright, and after that we need to add few more functions. So let's add a delete function. But before delete function, let me fetch a particular student. Let's say we want to fetch any particular student by sending out a roll number. Alright, so I'm going to write fetch data string roll number, and let's add an empty data object. Alright, so student data equals to null. Now let's have a reference to the first node of that linked list. So I'm going to take with the h.next because h simply contains the address of dummy node. I don't want dummy node, I want the first node that is after that dummy node. So that's why I've written h.next. Alright, so while p not equals to null, and inside this while I can check p dot data dot get roll number dot equals roll number that we have sent, and inside this if I can set the data to the p dot data, and I can then break. If we don't found, then we can iterate and go to the next node, p equals to p dot next. Alright, so outside this loop I'm going to return data. Alright, so we are done with the fetch data, and now let's write a function for deleting any particular student. So public void delete student, and I'm going to send out a roll number again. Alright, so let's add node p equals to head and q node q equals to h dot next. Alright, inside this while loop I need to check if q not equals to null and not q dot data dot get roll number dot equals roll number. Alright, then p equals to q and q equals to q dot next. Alright, this is the same logic that I used when I started teaching you what is linked list. Alright, So after this while loop, I need to check if q not equals to null, then p dot next equals to q dot next. Alright, else we can print anything that the data hasn't found, because this is only going to execute if we don't find any data in that list. Alright, so no data found. I'm just writing a comment rather than printing anything. No data found. Alright, so we are done with our delete function. The last function that I want to add inside it is the show all function. As usual, we write this function. So let's add public void show all. So node x equals to the h dot next. Alright, and while x not equals to null, then keep on iterating till the end of this list. Alright, but keep on printing out the data. So system.out.print line x dot data. Alright, it's automatically gonna call the toString function that is written in student class. Alright, and now keep on going to the next node. Alright, so I think that we are done with all the functions that are needed to be added in this student list class. Alright, so I hope that you have understood how I write this. Now I need to create another class inside this project, and that class is going to be our hash table class. Alright, so inside this hash table we need to set few properties first, because inside the hash table you know that we need to have a property that is array, because hash table only works with arrays. So I need to first add an array. And what is the data type of array? The data type of array would be the data type of this class, the student list class, because each index of that array is going to take the reference of the list of this type. Alright, so I'm going to create std list an array. Alright, the type of array is std list, and then I need to set the property size, that what is the size of array, and private int total students to check if we are done with all the students by inserting the students in this array or not. Okay, so let's add a constructor public hash table. Alright, I'm going to add a default constructor and set the default size 1000 and instantiate array with that size. Okay, so we are done with our constructor and properties. Alright, after that I need to write a function that takes the value. In our case, we are gonna give this function our roll number. This function is going to convert that roll number in the hash code, and that hash code will be used as an index in this array. Alright, so let's add int to hash code, and I'm going to give it a roll number. Alright, and so let's add two variables, int add ASCII. Add ASCII's, we can write any variable equals to 0, int code value equals to 0. Alright, and after that let me write the loop, and that's gonna start with 0 roll number dot length and I++. I will separate out individual character of this roll number, and I will keep on converting that individual character into its ASCII. Alright, and as I will sum, this loop is for sum the ASCIIs of each character inside this roll number. So I will add ASCIIs equals to the add ASCIIs plus, and in order to convert any character into its ASCII, we can simply typecast it to int. It will convert that character into its ASCII. Alright, so roll number dot character at I. Alright, it's going to separate out individual character, it's going to convert it into its ASCII, and this, at the end of this execution of this loop, this variable will contain the summation of all the characters of this roll number. Okay, and at the end, code value is going to take the mod of that summation to the length of array. So add ASCIIs mod array dot length. Alright, and I'm going to then return code value. Alright, so we have written our function that's going to return that calculated hash code, and after that let me write a function that is going to insert any object that is just created, any student object, into that particular index. Alright, after creating a node. So what I'm going to do is I'm going to boolean insert, and I'm going to send out key. Alright, and student data. I'm going to send out key that go to that particular index and store this data to that index. Alright, so I'm going to use this key to create a list object, and then inside that list object we have the algorithm that's going to create a new node, and that data will be stored in the new node. Okay, so inside this function I'm going to check if array key equals to null. Alright, I'm first checking out if that particular index of this array is empty or not. If it's empty, then it will be equals to null. Alright, if it's equals to null, then I'm going to create the new instance of object on that particular index. Alright, so array key equals to the new std list. Alright, and if it is not null, means one object was already stored in that particular index that is being sent with this key. Alright, then we don't need to recreate and assign that new object inside that index. Alright, so if it's not, then we are going to call the insert function, because we can, if this particular index is storing the object of this class, then we can also call these functions of this student list class. So now we can use insert student, and inside it we can just send data. Alright, and after that let's increment the student and return true to show that our data have been stored successfully. Alright, and just for convenience, we can check out that what are the different functions in the Java hash table class. Then we can write our own version of that functions, but I'm just trying to write all those major functions that are needed and that I think that I need to write in this class. Some function can be missing, but if your requirement have different things, then you can write your own functions. Alright, so I think that I need to add a function to get the total students that how many students have been entered in this array. So what I'm gonna do is I'm going to use total students variable and get total, and it's going to be return total students. Alright, and after this function, let me add a function to check if any particular student exists inside this array or not. Alright, so public student fetch std info. Alright, and I'm going to send out roll number. Alright, so I'm going to get the key by calling to the hash code, and I'm going to send out roll number to that function that we created up this function. Alright, so we have the key right here, and with this key I'm going to check if it's null, then I'm going to return null. If it's null means that it's not getting the reference of any list, and if it's not storing the reference of any list means the list is empty, means it doesn't contain any list, so there is no data with this roll number exist inside this index. Else means that this particular index contains the address of any list. Now we need to check in that list if that data exists in that list or not. So student q equals to array key dot fetch data that we created in our student list class, and I'm going to send out the roll number. Alright, it's going to return me that particular student. Alright, and then I can check if q not equals to null, then I'm going to return q. Alright, else I'm going to return null. Alright, and after that let's add another function, public, that is going to delete any particular student. Alright, we want to use this particular class. We don't want let users to know that we are using the linked list class. Alright, that's why we are just giving access to all the functions, all the required functions in this class, so that user may use this class. Alright, behind what is happening behind hash table, we don't want to expose it. Alright, because there are three different ways that I have already explained you that to avoid that problem of duplication. So behind that hash table what's going on, we don't want to show it to you. That's why I'm exposing everything inside this class. Okay, so public boolean delete std. Alright, and I'm going to send out roll number to delete it. I've already written a function inside my student std list class, and I'm going to use that one. Alright, first what I need to do is I need to convert boolean have. I need to check if that array, I'm writing everything in one line, so you shouldn't be confused with it. Alright, I'm calling out that particular function that I've just written above, and it's going to return me the key, and the key is being used as an index of this array. Alright, so and then when I get a key, I'm going to call the have roll number, and I'm going to send out the roll number. So it's going to send me true or false if that particular student exists inside it or not. So I'm going to check if that particular student exists. I'm going to get the key to hash code, and I'm going to give it a roll number, and with the array key I'm going to call the delete function, delete student, and I'm going to send out the roll number to delete that particular student. That is the hash code. Alright, and after that, once the student deleted, I need to decrement the student variable and return true. Alright, and outside it I need to return false. Total students. Alright, so we are done with our delete student function, and the last function that I think that needed to be here is to print all the students that are in this hash table array. Alright, again this class have the show all functions, but I don't want let users know who are using hash table class that behind the hash table class I am using student list class. Alright, so that is a good practice to expose everything if you want to give access to one class to the users. So public void show data, and for int I equals to 0 and I less than array dot length and I plus plus. Alright, inside this for loop I will, if I equals to null not equals to null, alright, then array I dot show all function. Alright, this show all function is inside this class, and I am checking out if any particular index is not null, means that index have the list reference. So go to that list and print out all the elements inside that list of each index of this array. Alright, so I hope that you have got the idea how I am organizing this hash table class. Now I need to go and use this hash table class. I am to test out by inserting a student, by deleting a student, by printing out all the students. So let's go to the main class and test this out. Now first we need to create an object of our hash table class. So hash table equals to the hash table. Alright, we added default constructor that is setting out the 1000 size of that array. Alright, but first, before inserting any item, we need to create the objects of student. So inside it, let's create std1, and inside the student I'm going to send out name, roll number, alright, and lastly we need to send out CGPA. Alright, so 3.4. Alright, I'm going to copy this line. It's giving me error. This CGPA is of double type, so I need to remove these quotes. Okay, so I'm going to copy this line and I'm going to paste it. Let's change it a bit. 453 233 3.1 and 3.2. Alright, so we have created different objects of student class. Alright, now if we want to insert these objects inside our hash table, inside this array, we need to send out the data that we already have right here, and we need to send out key. So first we need to find out key by sending out the roll number to this function. Alright, so what I'll do is int std1 key equals to hash table dot to hash code, and I'm going to send out std1 dot get roll number. Alright, so it's going to send out the 15-123, and this function is going to convert that particular roll number into its hash code, and that hash code will return the key inside this variable. So I'm going to copy this line and paste it right here, and I'm going to change the variable names right here as well. Alright, now in order to insert this particular student inside this array, I can use the insert function and I can send key and data. Alright, so hash table dot insert, and I can send out student1 key and data is std1. Alright, so let's copy this line and paste it right here. Let's send out student2 and student3 with the key of student2 with the key of student3. Alright, and in order to check out that if it's working fine, I can use this show all function to print that up. It's going to go this function show all, and it's going to print out the data. Alright, the data means that it's going to call up this toString function. It is the default function in the parent object class. Alright, and that is being overridden in this class. So I'm going to call out hash table dot show all. It's show data. Okay, so now let's run it. Alright, so you can see that it has printed all the data that we added inside that hash table. It's really complex. You must know the idea that how the compiler is processing this data. Alright, right now I want to add another object in order to check if the duplication is being resolved pretty well or not. So I'm going to create a student4 with the name let's say OS. Alright, and I'm going to send out 3 to 1. Alright, and this roll number is going to generate same hash code like this, because there is order different, but when this the ASCII codes of individual character of this roll number is going to summed up, it's going to be same as this one. Alright, so I need to check if this one overrides this or not. If it doesn't override, means our code is working pretty well. Alright, so I'm going to copy this line as well, and student4 key, and I can use student4.getRollNumber. I need to insert this student4 as well, so student4 and std4. Alright, so I should get 4 objects in the console. So let's run it. Alright, so you can see that it has printed all the 4 objects, but it didn't override all those things. So that's why we used linked list to avoid that problem. If we were not using the linked list and we were just finding out the hash codes and then storing the objects, then this object is going to override this particular object. So everything, any index that this particular roll number is generating, that is going to create a linked list, and that linked list is going to have 2 nodes, one for this and one for this, in spite of the fact that both are generating the same hash code. So I hope that you have got the idea. Now we have tested successfully our insert function, alright, and our hash code function as well. Now we need to check out, it's pretty simple. Now we need to check out fetch student info, alright, if it's working fine or not. Alright, so it's going to return me the student, and then I need to call with student, and then I can call the toString function of that student. Okay, so let's comment this one, and inside this function I need to send out the roll number. Alright, so hash table dot, it's not giving me hint, I don't know why. I need to copy this function so that there is no spelling mistake. So I need to send it out a roll number. So let's say that I want to send out std2 dot get roll number. Alright, so it's going to return me a new student object, new std2. Alright, and now I need to check if the new std2 dot get name dot equals std2 dot get name. Alright, so this way I can check if the returning data that is being returned from this function is same as the data that I sent right here or not. Alright, and then I can simply print out equal. Alright, so let's run it. So you can see that it has returned me equal. So over this function have been tested, it's returning me the exact information that I wanted. Now let's delete this. I have already tested the show all. Now this function is remaining. I need to test this one as well. So let's go and delete any particular function. I need to copy this code. Alright, let's uncomment this line, and after inserting individual data, I want to delete any one of these. So let's copy this one, delete std, and it needs a roll number. So let's delete this one. Okay, so std3 dot it's not giving me hint. I need to call get roll number. Alright, so this function has to be, this object has to be deleted. Now let's run it. It should return 3 objects. So you can see that it has printed Awais, this one, it has printed Umair, it has printed Ali. Alright, so I hope that you have got the idea that how I'm using individual functions. I'm not calling any of the function that is inside this std class. I could also create all this functionality inside this class, but I'm separating out the different logic in different classes and different sub logics in different functions. Alright, but in the main class I'm just using hash table class. I don't know that there is anything exist behind this class or not. So guys, I'm done with this tutorial. It was the longest tutorial I have ever made on YouTube. So I hope that you have got and learned a lot from this tutorial. It was a pretty lengthy and very knowledgeable lecture. So make sure to thumbs up this video if you like it, share it with your fellows, and subscribe my channel for more videos on programming, game development, mobile application development, web development, and make sure you join my Facebook group that I have given the link of that group in the description below. Thanks for watching this video.